Hi guys, today I would like to talk about cache management on Apollo Client 3. But before diving into details about cache specifically on GraphQL or Apollo, we need to take a step back and see how cache works on the web in general. What is cache and why it is necessary? Cache data is stored on your computer or phone when you browse the internet. And it's really important because it decreases the response time of a web application. And by doing that, it also avoids unnecessary requests to the server, which reduces the bandwidth and benefits the user. But there are two kind of caches, which is the server-side caching usually is done by using NoSQL databases such Redis. Then you can save the data on the database and retrieve it later on. You can also perform client-side caching. There's many ways to do client-side caching, but one approach that have been used since the 19s is client-side caching through HTTP protocols. And we use the HTTP headers, can be less modified, cache control, etc. And by using the HTTP headers, you control the client-side caching. We have control over the browser requesters from the server. But I won't get into details about client-side caching in general on the web. But if you want to take a look and get more details about it, I will put a link right here about the W3, where you can get to know HTTP caching better. And client cache, local storage, session storage, all of these things have one thing in common, that is persisting data on the web. So by persisting data on the web, we improve the user experience, because the user doesn't have to reload the page. The user doesn't have to lose data when going back to a step on a form, for example. And it's really important to persist data on the web in order to improve the user experience. But dealing with cache on GraphQL isn't easy, and the reasons for it is that GraphQL API hits a single endpoint, and it's also hard to predict the response because of the flexibility of the fields. GraphQL clients send bodies to the server with post method instead of get methods, and Apollo client provides an abstraction layer to manage cache, which makes our life easier because we don't have to manage the cache data directly. There's a layer of abstraction there of the cache API that Apollo client exposes, and we just need to learn how to deal with this API. But what happens when you learn how to deal with the API, but not on the right way? You end up having unnecessary network requests because maybe there's some data that you're not caching in the right way, or you're using the wrong fetch policy and leading to a bad UX, a bad user experience. We'll talk more later about the fetch policies, what each one does. Or maybe you're caching the wrong entities, because there are kind of entities that doesn't need to be cached at all, and you doesn't know how to disable the cache for these specific types. But in this talk, we are going to cover the following topics related to cache management on AC3. We're going to talk about cache normalization, fetch policies, type policies, field policies, and how to perform pagination through field policies. Cache normalization is really important on AC3. AC3 uses in-memory caching, which is a normalized data store. But how it is the process to normalize the cache data, and what is normalization at all? Data normalization isn't something just related to Apollo or GraphQL, and data normalization is a technique very important on databases, on relational databases, and it is really important in order to reduce data redundancy and also to improve data integrity. So as you can see on this image, we have two tables, and instead of duplicating the registers of the tables, we are just referencing them by unique identifiers. So in databases, we usually have primary keys, foreign keys, or other kinds of constraints that make the registers be unique. And on Apollo, the normalization algorithm also creates unique identifiers for each response object. But there are some steps, which is the response data is split in different objects, and each object receives a unique identifier, which is calculated by the ID field and the type name field. The normalized items are started in a flat object, and then when we execute other kind of graphical operations such as mutation in order to edit a specific item, the fields of those objects of the new data coming to the response will be identified as already stored on the cache by a unique identifier, and those fields will be merged and the cache will be updated. But in order to understand better the process of normalization, I will show images of the process of the algorithm, and I'll also recommend you guys to check out this article, Demystifying Cache Normalization, on the Apollo GraphQL blog. It's really good, and I think will clarify your mind about the cache normalization algorithm on Apollo. But the first step is when we are executing the query, Apollo client will execute the query and the Apollo server will return the response data. The response data will start to be normalized by Apollo client by splitting the response data in individual objects. So by having these individual objects, we are able to assign unique identifiers for each one of these objects, because we don't want to have redundancy. We also want to reference these objects in order to merge the cache data, to update the cache data. By default, Apollo uses the ID field and the type name. But what happens if your entity doesn't have an ID field, but instead you have other kinds of fields that are unique? Apollo exposes an API in order to customize the unique identifier of a certain type by setting a type policy, which we are going to talk more later about type policies. But by setting a type policy of a certain type, here we are showing an example of the user type, and setting the key fields property, we are able to change the keys that are used, the fields that are used, in order to assign the unique identifier for those normalized items. And here specifically on this example, I'm saying that the user has a unique field called email, and that will be used plus the type name in order to assign and calculate the unique identifier. So it's really important to don't forget to fetch these unique identifiers of a type, because by not fetching the unique identifiers of a type, the response data won't be normalized and the cache won't be correctly stored. And by accessing them later on, we are able to update the cache. So all of the normalization process will go wrong if you forget to fetch these IDs, these unique identifiers, because we are going to be able to access them on the store. The process of merging the fields won't work as expected. And after normalizing these items, we are able to put these items on a flattened data structure. And these items will be stored on the root, and the keys will be the unique identifiers that we mentioned before. But since it's a flat structure, the objects are accessible through their unique identifiers. For example, here I'm just simply how easy it is for Apollo behind the scenes access these normalized items and update the cache. Because imagine that these unique identifiers are just strings, and they are mapped on these flat data structures. So now what Apollo needs to do is access this flat object using this unique identifier, and it updates the fields, it merges the fields. So it's really fast. And besides storing the normalized items, the normalized objects, the carries are also stored in order to maintain the list items order. So when you execute the carry for the first time, the data will come from the server and will be saved on the cache. But the list of items came with a specific order from the backend, right? And at the second time that we execute the same carry, we want the same order. We don't want to use the order. So that's why Apollo also saves the carry, and it references the unique identifiers in order to not repeat the normalized items and have data redundancy. But let's dive into cache policies in order to understand how to use the cache data and how Apollo performs all the logic with by doing network requests and returning the cache data. What are the types of cache policies that can affect the process of caching and returning the data to the client? So basically, the default cache policy from Apollo is cache first, and the cache first fetch policy executes the carry and checks for the cache data. So if the data is cached, it's going to be returned directly, avoiding the network requests. If there is no cache data, Apollo will make a network request in order to get the response data and save it on the cache. So the user at the first time will probably see a loading spinner, but after the response data comes, the data will be normalized and saved on the cache. So at the first time that the user open the page and execute the request, the data will come right away from the cache. We also have another cache policy called cache and network. It is really recommended for data which is frequently updated. For example, social media applications where the users are interacting every time and the data is changing every time. So this cache policy will always return the up-to-date data. And by executing the carry, it checks for if there's cached data. If there is cached data, it's going to be returned directly. But even if there is cached data or not, Apollo will make the network request in order to get the up-to-date data, and then we will update the cache. So the key point here is that the user will always see the cached data for the first time. The user won't have to wait. But after some milliseconds, while the network request is being done, Apollo will update the cache, so the user will see the data changing, but without having to see a loading spinner. And there's another one called network only. This policy will never return out-to-date data because the network requests will always be executed and the data will be saved on the cache store at the same time. It executes the carry and makes the network requests, but it also saves the data on the cache. So the key point here also is that it doesn't return the cache data, but it saves the data of the response on the cache, because maybe you ain't gonna use the cache data on a specific carry of the type, but let's say that you create another carry and you want to grab the cache data instead. You want to use one fetch policy here, another fetch policy, which grabs the data from the cache. So it makes the network request anyway, but this fetch policy also saves on the cache the data, maybe if it doesn't use it at all. And the next one is no cache. No cache, it's really similar to network only, but it doesn't save the data on the cache. So you can reuse it later on. It's going be pretty straightforward. It's just going to execute the query, make the network request, and the server responds with the data. But there are some situations that we have to update the cache, right? And Apollo will update the cache automatically if the mutation response always return the new data with the same type as the query object in order to retrieve the unique identifier and merge the cache data. So there are situations when the cache is going to be automatically updated by editing a single entity and returning the same time on the response object, or by editing many entities and returning the same types on the response objects. All the components executing the query will get hangry when the cache is updated. But life is not easy, and there are cases when the cache isn't automatically updated because the merge isn't possible. When the merge isn't possible, for instance, if you have a query which returns a user and you execute a mutation to, let's say, edit a user, right? So instead of the mutation returning the updated user, the mutation returns a Boolean. So there's no way to Apollo merge the fields because they aren't related at all. Other situations is the entire set of objects isn't returned on the response data, the mutation doesn't return the data with the same order as the cache data, and the mutation adds or removes items. And the cache doesn't know how the list of items should change in these cases, so we need to update the cache manually. And how can we do that? So we use the update function to update the cache manually. And one example here is when you are adding an item, so you are executing a mutation in order to add an item. And the update function is pretty straightforward. It receives the access to the cache API as the first argument, and as the second argument, it receives the response data. So by doing it, we are able to write to the cache again, and we can also deal with the case when we are deleting an item. When we are deleting an item here, we are reading from the cache, reading the existing data from the cache. Then we delete the old data using cache.write query. We are writing the new cache data, and we delete the old data using cache.evict. We also can disable the cache normalization because there are situations when the specific entity doesn't need to be cached at all, for instance, search results. So it doesn't make sense to run the normalization algorithm behind the scenes if the data isn't going to be cached, or if it doesn't need to be normalized. It doesn't need to avoid redundancy. So let's say that we want to cache the data, but let's say that you doesn't want to avoid redundancy. You just want to cache the whole list of search results without assigning a unique identifier for each one. So AC3 provides an API to customize how the cache interacts with specific types by mapping the type name to type policy options and creating a new in-memory cache. So as you can see here, I'm setting two type policies, one for search result and the other one for user. And on one type policy, I'm disabling cache normalization. In the other type policy, I'm setting a custom field in order to generate the unique identifier for the normalization process. We have the field policies, which is used to customize the behavior of cached fields. And in that way, we are able to customize how a particular field is read or written in the cache by providing a read and merge options. So here I'm saying that when I'm going to retrieve the name from the cache, when Apollo client goes and retrieve and read the name field from the cache, it can assign the unknown name string if it doesn't exist, or I can also specify a custom merge function. So when Apollo client goes to merge the author field, he always prefers the incoming data instead of the existing one. So as you can see, the field policies are very powerful. And one of the ways that we can use field policies is also with pagination. But AC3 now explores pagination helpers, which is really useful because pagination logic isn't related with any specific entity at all. So we can share it across application and across models and across entities. So here I'm using offset limit pagination on a specific type. And the ingredient here, the array with the ingredient string, is the array of key args that really make this field unique. So I want to save the value variations of that field by using the ingredient arg. I don't want to use offset or limit, but the only arg that really meant here is the ingredient one. And that's it. I hope you guys enjoyed the talk, and I hope that now you have a clear mind about how Apollo handles the cache for us. Also, I just want to remind you to read the article about cache demystifying cache. It's really good. And that's it. See you in the QA.
Yeah, we're super happy to have you. That talk was absolutely phenomenal. And we've already got a bunch of questions poured in, so I'll just actually jump right into it. Our first question here, you talked about cache normalization. Is it recommended in any way to disable cache normalization?
So that's a really good question. It isn't recommended to disable cache normalization. It's really some specific cases like search results, but in most part of the cases, you don't want to have redundance, like duplicated data on your cache store. So I don't recommend at all to disable cache normalization.
Awesome. Don't worry, we got more ready. Laura, what are some examples when you might want to use key fields to segment your cache?
Key fields. Maybe if you want to avoid using unnecessary key fields like I'm still thinking about it, but
take your time. We can always come back because we have a bunch more questions at the ready. So if this is something you want to kind of circle back on towards the end, more than happy to move on.
Yeah. I think we can go to the next question, and I'm still
no problem. Cool.
Be thinking about it while.
No problem. Well, our next question here is, what resources did you find most useful for learning Apollo Client 3? And what do you think could be improved in that space?
The strings that Apollo does, it's really good, and also the YouTube content about it. But in general, I read a lot of articles about cache issue on the Apollo blog. And the blog really teaches me a lot of things about Apollo client. So the blog of Apollo and the YouTube channel to read all of the content that Apollo does, it's really important to learn about Apollo client.
That's awesome. Is there anything that you think could be improved?
Actually, I don't think so. But a lot of the examples that they bring are awesome. And the live streams on Twitch, especially, I love it because it's really natural. I can watch it while I'm working or doing anything else.
Yeah, I agree. The content that comes out of Apollo is always some of my favorite, and I absolutely love their live streams. One of my favorite things to tune into. Our next question here is, what do you think about integrating Redux with Apollo client cache management?
That's a bad practice in general because Redux deals with the client state management, and the server side data is totally async. So the idea is that you end up dealing with some weird things regarding to cache. All of those things Apollo already handles for you because it has an internal store, the cache store. So you really have to focus on dealing with the server-side data on Apollo and not persisting to another store, especially being a client one like Redux or Zeuston, any kind of client state management library.
Yeah, I agree. I think that's one of like the really cool things about Apollo is how much it handles a lot of that for you out of the box. And I think one of my favorite things is when they introduced the hooks into the React ecosystem and how easy that made interacting with that cache and controlling your data. I feel like it was like night and day from the whole render props move that was previously there. So the questions keep pouring in. Let's see. All right, cool. How do you think about using optimistic responses with the update function?
It's it's a really good idea to have optimistic responses. I think it is optimistic updates in general, right? Is the same thing, optimistic responses.
Yeah,
Um,
basically like updating the UI based off of what you believe the change will be.
I see a lot of people also using refetch carries, the refetch carries option all the time. But in the end of the day, you are really refetching a lot of stuff. And imagine if you have a huge list, it will be easier for you to update the cache manually and avoiding to redo redo the request than abusing the request carries option on the use mutation hook. So it's a really
Mhm.
good idea to use the update option to do optimistic updates on the cache.
Definitely. And we probably have time for about one more here. So I'll just feed you this real quick. What do you think about using Apollo Client Cache for local state management?
Uh, it's really nice. Now Apollo client has this thing called reactive variables, and you can using a single star. So you have client data and the server side data in one single place. I think that's really nice because you don't have to worry about having another library to deal with a star.
Mhm.
So two stars on the same app, one star to deal with cache and the other star to deal with client data, and you can have just a single one. I didn't read a lot about it, but I really recommend you check the docs, and there's some good content that Apollo did about it too. But it's really nice.
Yeah, I definitely think it's come a long way as far as how you can start to handle your server and client together and really start to use those reactive variables to start to make a difference in kind of the way. Because I think the really cool part is it really lets you control what the user is expecting, and it really lets you really give them a nice UI flow based off of incoming data from the server, anything that's changing for the UI. It's kind of all nicely handled within one kind of state tree instead of having to combine multiple state trees and hope that they all keep up with each other.
Yes, exactly.
Awesome. Thank you so much, Laura. Phenomenal talk. Amazing Q&A. If anybody wants to find Laura after the talk, go ahead and hit her up on Twitter. If you have any more questions, your question didn't get answered today, definitely reach out. Laura, thank you so much and have a great day.
Thanks. I'm really glad to be here today. And if you guys want to ask me anything, go to social medias and I'll be there.